Alright, so now I want to look at this system of linear equations, and I'm going to solve it in the way where I'm going to be adding equations to each other to try and eliminate a variable. So I'm looking at these two x's here, and I think that if I subtract one equation from the other, then I'll be able to eliminate an x. So let's see, let me just subtract, let's see, since the 5 is bigger, maybe I'll rearrange things so that I've got x plus y minus z equals 5 on top, then x minus y plus z equals 3 below it, and then negative 2x plus 4y minus 4z equals 1. So it's totally fine to rearrange the order of your equations. And now I'm just going to subtract the first and second equations. Okay, so when I do that, this is what I get. The first equation stays the same. The second equation, I get, let's see, x minus x is 0. I have y minus negative y would be 2y, right? And then negative z minus z would be negative 2z. And then 5 minus 3 is 2. Okay, and then I still have the same equation below that. Now it would help if I kind of could write things nicely so that everything was sort of, we could see how things lined up, right? Because then it's easy to see how to cancel out a variable. So I'm sorry my equations got kind of squished. Let me rewrite it so there's a little more space. Okay, so I eliminated one of my x's though, and that was good. That was what I wanted to do. Okay, I'm going to try to really write things. So then I've got a 2y, I've got a 4y here, I've got this negative 2z, and minus 4z. And remember, this is now 2. Nothing changed from the third one. Now let's see, I want to get rid of this, this negative 2 here. So what I'm going to do is multiply the first row by 2. And when I do that, I get 2x plus 2y minus 2z equals 5 times 2 is 10. Alright, didn't change that middle row at all. Let's see, we'll have a 2y, a negative 2z, 2, and it didn't change that last row at all either. Alright, so now let's do, let's just add the first and third rows, right? Because if I add them, 2x plus negative 2x is 0. So we'll add first and third. And I'm talking about those equations here. Okay, so let's see what happens. Looks like I'm going to need a new page. I'll just draw an arrow down. So 2x minus 2x. Well, first, let's write down our first two equations. I have 2x plus 2y minus 2z equals 10. That second equation is 0 plus 2y minus 2z equals 2. And then now I'm going to subtract this last equation from my first equation, which I can just see at this top page. or sorry, I'm going to add these two together. I apologize. So when I add 2x to negative 2x, I get 0. When I add 2y to 4y, I get 6y. And when I add negative 4z to negative 2z, I get negative 6z. And then I'm adding 1 to 10, so that'll be 11. Okay, so now let's try to get rid of y's. So the idea is just to eliminate one variable at a time until you finally just have one variable and a number. And that's just saying, okay, now I'll know like what z is equal to. Okay. So let's work with my first and second equation. Maybe I can use this 2y to eliminate the 6y from the third equation. So if I multiply that second equation by 3, that should do it. Let's actually multiply it by a negative 3. So I'm going to multiply the second equation by a negative 3. So nothing changed from that top one. Maybe I'll put a line in here just to say this is kind of a separate step. Okay, so if I multiply by a negative 3, that's still 0. I'll get a negative 6y, which is good because I want it to cancel out with that 6. Let's see, negative 3 times negative 2 will be a positive 6. And then this is a negative 6 here. And there's my last equation. Alright, so when I add these two equations together, I got 0, 0 plus 0 is 0, plus negative 6 plus positive 6 is a 0. 6 plus negative 6 is 0. What does that equal? Okay, still need to add these last terms. Negative 6 plus 11 is 5. Okay, but what does this mean? 5 equals 0? So try to think about what this means for our system of linear equations. I'll leave off with that. Maybe put in the comments what you think it means to have this 0 equals 5.